All right, this question deals with vector addition and vector subtraction, really, because when we read it, it says if x is equal to y minus z, which diagram best represents the vector z? So it shows us first the diagram, two vectors, x and y, and they are drawn to scale. So it's like x is a vector that points up and to the left, and y is a vector that points to the right. Remember, these could represent forces, momentum, displacement, lots of different things. All right, and so it's way easier to add them, right? So let's see, if x is equal to y minus z, so we want to subtract one of these from this to get that. Okay, well, let's start by adding them. Okay, and so like I'm gonna make it like y plus z, and then it maybe makes it a bit more clear. If I added, let's say, c to y, you just put them head to tail, right? And then you'd connect the dots. And so the sum of x of y plus this, we'll just call it z prime for now. We don't know which is the true z, right? But it'll be our and I prefer, instead of adopting sort of a tail to tail method where you can subtract vectors and tail to tail and sort of that way, you can simply add them with the rule of this vector's head and tail, connect the tail of the first and head of the last vector, but just make the second vector the negative of it, in other words, flip its direction. So if I was just entertaining this y plus z prime, we're calling like this c right here, z prime right now, and I get this solution, well, that vector is not that one. But what if I subtracted them like it suggests I do? Well, then I'd have y, instead of adding z, this would be y minus z then, right? You just sort of flip the direction. So this is positive z prime, so negative z prime would just be down. And then again, you still have the same rule, connect the head to the tail. And that's the difference between y and this z prime, which again does not agree with x, right? We're looking for x is the difference between those. And so we've eliminated this one. Kind of hoping it was that one because it's kind of simple to add up or down. So let's sort of get rid of that. And let's just use that same strategy to work through all these until we figure out which one is it. So again, it's kind of easier to say, well, what's y plus d, right? So d goes down, so that would be this answer. So if I subtracted this vector, then it would just go that way, and it would be where I sort of started with this one. And again, that's not right, nor is that right. So neither C nor D could be the correct answer. So like, okay, back to the drawing board. Let's try to subtract this one from it. So if I added it to it, again, there's the tail of it, but head to tail would go there. But then if I subtract it, so adding y plus b, okay, would go like that, and the answer would actually go like that. So that would be your solution right there. If I added it, but I'm subtracting it. So instead of going this way, it's going to go the opposite. It would go down like that. And that would be my answer for B, which again, this does not agree with that. But just like we sort of saw, well, this is the opposite of that. Well, this is the opposite of this one. You see how if we added this one to it, it would have been it, right? So that gives us sort of the solution there. Well, that means when we subtract this one, it will give us the solution. So we kind of know A is right. Let's make that very clear. Okay. So we're going to add vector A to it, put it head to tail. It would go something like that. That would be the sum of y plus A. But I want to do y minus, so z now, right? So saying which one of these is z? Well, A has got to be z, right? Because if we added y plus z, we get that. But if we flip the direction of this, right, it's going to point sort of back up that way. And it's clearly longer than y, right? It is to scale. So y minus z, there's negative z. Y minus z would give us this difference, which is indeed that. So we can kind of prove that it must be vector A. If you think through it carefully, you'll probably get the answer correct. But you have to know the rules.